Welcome back to College Algebra. In this lecture video 4.4, let's take a look at construct polynomial functions with given properties. So these problems is a little bit of work. So let's just grind this thing out real quick. All right, construct a polynomial function with the following property. Oh, be careful how you read this, okay? See where the comma is? The comma is trying to separate all the property or the information trying to give you. So let's read this one at a time, okay? Fifth degree, comma. So that means my final answer will be x to the fifth power, okay? So, all right, next information. 3 is a 0 with multiplicity of 3, all right? So what that means is by the even odd multiplicity, okay, the multiplicity is actually located, all right, as the exponent, all right, of a factor. It's actually on the exponent where a polynomial function is already factored. Okay, so that means, all right, let me go ahead and write it out. Okay, 3 is a 0, so x is equal to 3. So if I move my 3 over, that will become x minus 3. All right. If I write them in the factored form, it look like this. The exponent is actually 1 right now, but it tells me 3 is a 0 with multiplicity of 3. So that's actually x minus 3 to the third power. Next piece of information. Negative 4 is the only other 0. Okay, what does that mean? Let me write the multiplicity down, okay? And I'm just saying MULT. Multiplicity for the 3 is 3, right? 3 is a 0, multiplicity is 3. Negative 4 is only other 0. Well, if the multiplicity on the negative 4 is 1, then when I add up my multiplicity, it's not going to equal to 5. So that means this negative 4 got to have multiplicity of 2. All right. It says negative 4 is the only other 0 I'm going to have. So now 3 plus 2 will make it 5. So that means if I move my negative 4 over, I will get x plus 4. Then to the second power. Multiplicity is 2. All right. So now we just have to grind this out. Multiply everything out because I do have a leading coefficient of 2 as another piece of information. All right. So that means, you know what, let me erase this real quick. That means in a linear factor form, this ace of n that I showed y'all in the previous video, this ace of n here will be a 2. All right, so I'm going to have my 2 right here as leading coefficient, equal sign right there. So I'm not going to worry about this 2 until the very end, okay? I'm going to multiply all these things out. So x plus 4, whole thing squared. If you want to, you can multiply this out on the side and write it as x plus 4 times x plus 4 and fold it out. All right, since I know my perfect square binomial formula, I know quickly this is going to be x squared, all right, plus ax plus 16. All right, so I'm going to put it right there. Now, x minus 3 to the third power, that will take a little bit of work on the side, so I'm going to kind of do my dash line right here. All right, so I'm going to do this one like this. I'm going to do x minus 3 squared first, then x minus 3, okay? So what that means is I will do the x minus 3 whole thing squared first using the perfect square binomial. Remember, a minus b whole thing squared equal to a squared minus 2ab plus b squared. I'm just going to use that formula to come up with a quick answer. X squared minus 6x plus 9 Now, if you want, you can write this out as x minus 3 times x minus 3 forward out. Then you will get the same thing as I do here. Then times by x minus 3. All right, I'm going to just go ahead and quickly do this, okay? So x squared times x times negative 3 is x to the third minus 3x squared. Negative 6, do a distribution. That will be negative 6x squared. Sorry, that's a square. X squared times negative 3x squared. Negative 6 times x, negative 6x. Negative 6x times negative 3 is positive 18x. 9 times x is 9x. 9 times negative 3 is negative 27. All right, combine like term. I'm going to go ahead and combine and write my answer here, okay? 2 up front. X to the third is still x to the third. Negative 3 minus 6 is negative 9x squared. All right, 18 plus 9, I believe, is 27. And then minus 27. All right, now I got these 4 terms, need to time these 3 terms. All right, grind this out. All right, let's multiply, okay? Grind it out. All right, put my 2 up front. I'm going to write a big old parenthesis right here. All right, just I'm going to write this out so you can follow along. X to the third times these 3 terms. X to the third times x squared will be the x to the 5th. X to the third times positive 8x is positive 8x to the 4th. X to the third times 16 is positive 16x to the third. Negative 9. Negative 9x squared times these 3 terms. It sure bothers me when I see that sign right there. All right, negative 9x squared times 9x squared, negative 9x to the 4th. Negative 9x squared times positive 8 is negative 72, x to the 3rd. Negative 9x squared times positive 16 is negative something x squared. 9 times 16. 9 times 16, 144. Negative 144 x squared. Ooh, this is going to be long. 27 times x squared is 27x squared. 27x times positive 8 is positive. Oh, I messed up already. 27x times x squared is 27x to the 3rd. All right, make sure I didn't mess up my exponents real quick. Then negative 9 to the 3rd to the 4th. Yep. 5, 4, 3. 5, 4, 3. 4, 3, 2. 4, 3, 2. Yep. Negative 27x to the 3rd times that. Excuse me. Positive 27x times x to the 3rd is that. Positive 27x times positive 8. 27 times 8. 216. 216x squared, right? X times x is x squared. 27 times 16. 432 x. All right. Now the negative 27. Now I'm going to write this one out. I just used a positive 27. Now I'm using a negative 27. So the negative 27 times x squared is negative 27x squared. The negative 27 times positive 8 will be negative 216, right? Same thing as the 27 times 8. Negative 216x squared. No, just x. Negative 27 times positive 16 is negative 432. All right, so let's combine, okay? So 2 still up front. X to the 5th, got nobody combined with, still x to the 5th. I'm going to scratch it off. All right, 4 power. 4 power here, 4 power here, nowhere else. 8 minus 9, negative x to the 4th. All right, 3rd power. third power 16 minus 72 plus 27, right? The 16x to the third is positive, right? 16 minus 72 plus 27, that could be negative 29. X to the third. All right, done with that. Scratch it off so I don't have to look at it. All right, x squared, negative 144, positive 216, negative 27. All right, negative 144 plus 216 minus 27. Positive 45. X squared. All right, done with that. Cross it off, cross it off, cross it off. So now I just got 432 minus 216. 432 minus 216. 216. And the negative 432 got nobody combined with. Negative 432. All right, so finally, now distribute my 2 so I can have my final polynomial. So my f of x will equal to 2x to the 5th minus 2x to the 3rd minus 58 x to the 3rd plus 90x squared. 2 times 216 is that 4, where was it? 432 x. All right, minus 864. All right, so that's my polynomial function. Whew, that's a lot of work just to come from such a tiny little thing up here. Okay. All right, try another one. Oh, this one is with the y-intercept, got to be negative 15. All right, consider a polynomial function with the 3rd degree. Oh, 3rd degree is a lot easier to do. All right, so n is equal to 3. Only real coefficient, comma. I only have real coefficient. Okay, let me see if up here. This is a little bit different, right? The previous one doesn't say that wording, only real coefficient. So what that means is none of my coefficients, okay, were involving with an I. Coefficient is involving with an I, okay? Negative 1 and 2 plus I are 2 of the 0. So x equal to negative 1 and x equal to 2 plus I. Well, by the conjugated theorem, if I have a 2 plus I, that means I should have 2 minus I. All right. So remember, I only got 3 degrees, right? So when I move all these terms to the other side, all right, and write them in factor form, I'm going to leave a little space for my leading coefficient, okay? So that will be x plus 1 times x minus 2 minus I and x minus 2 plus I. The multiplicity on each one got to be 1 because 1 plus 1 plus 1 will be the degree 3. All right, so the only thing I got to worry about at the end is my y-intercept is negative 15. So what I'm going to do is multiply this out first, see what my polynomial is, then I will incorporate my y-intercept. Because that means in my final answer, the last term got to be negative 15 because that is actually my y-intercept. So I'm going to do these two first because this two is very, very interesting. Rather than FOIL out, I'm going to put this right here, okay? Rather than FOIL this out, if you can recognize the pattern here, it will definitely help you out a lot, okay? So, give you a big hint, this part. If I treat the x minus 2 in the 2 parentheses as an a. I will be the b. 1 minus and 1 plus. What is this? What is this? This is what? Difference of squares. All right. So that means this is my a and this is my b. So if you remember difference of square, that means my a will be squared minus my b, which is I, will also be squared. Because if you see it this way, you can actually know what these two multiplied together will equal to. So by the perfect square binomial, I can multiply this out to be x squared minus 4x plus 4. All right, well, I squared is normally -1. -1 times this negative will make a +1. So that means when I combine like terms here, these last two multiplied together will only be x squared minus 4x plus 5. All right, now I will multiply my x plus 1 up front. So let's distribute. All right, x times x squared times -4x times +5. So that will be x to the third minus 4x squared plus 5x. +1 dual distribution will be +1x squared, -4x, and +5. All right, remember now, there's a little bit of leading coefficient up front, okay? I'm not writing it. Okay. I'll go ahead and put them in the parentheses now. So combined like term, that's going to be x to the third minus 3x squared plus x plus 5, okay? Now, how do I deal with this leading coefficient? Well, you probably remember a problem like this before in other section. Y-intercept means find y when x is equal to 0. So, if I were plugging 0 for all my x's and -15 is a y value, put it on the other side where f of x is, then I should have -15 equal to the leading coefficient that will make this last term into a -15 times 0x to the third minus 3 times 0 squared plus 0 plus 5. So if you know plugging 0 in all this x will make all these terms go away, you can just go ahead and say, well, this is just going to be -15 equal to s of n times 5, right? So my leading coefficient here by itself, divide both sides by 5, got to be -3. So this leading coefficient here got to be a -3. Everybody okay? So if that's any coefficient term to be need to be a -3 in order to have a -5 as a y-intercept back here on the last term, then I can just go ahead and distribute. Okay, you can just look at it. You can begin to write out your answer or key in your answer on the computer. So that will be -3x to the third plus 9x squared minus 3x minus 15. Okay. So that will be my actual polynomial function. All right, so a little bit of work on problem like these. This is as much work as we can do for college algebra. All right, that will conclude this lecture video. Thank you for watching.